In this video, I am going to explain Maxwell's equations and electromagnetic waves, which comes under Module 3 of video syllabus. So here I am going to discuss about Gauss divergence theorem, Stokes theorem, and Faraday's laws of induction. Now, let us concentrate on what is Gauss divergence theorem. The theorem states that the surface integral of the normal component of a vector function f over a closed surface S is equal to the volume integral of divergence of f taken over the volume V enclosed by a surface S. Or it states that the volume integral of the divergence of a vector field f taken over any volume V is equal to the surface integral of f taken over the closed surface surrounding the volume V and vice versa. That is integration S, that is surface integral f dot ds is equal to volume integral del dot f dv. Here the divergence of vector f is defined as the total outward flux of vector f through a closed surface. Next, in electrostatics, that is in electrostatics, the Gauss divergence theorem can be defined as surface integral of a normal component of electric flux density d over a closed surface S is equal to volume integral of the divergence of electric flux density through the volume enclosed by the surface. That is, surface integral d dot ds is equal to volume integral del dot d into dv. Next, here is a picture. So here we have to consider that the volume V enclosed by the surface S is made up of a very large number of elementary volumes for convenience in the form of cubes or rectangular parallelepipeds adjoining each other. Let one such cube of volume dV with its sides along the three axes x, y and z are dx, dy and dz respectively, that is as shown in figure. If fx, fy and fz are the components of f along x, y and z directions respectively, then the outward flux through the left is given by minus of integral fx dy dz. Next, the flux through the left and right faces is given by del fx by dou x into dx dy dz. Similarly, flux through top and bottom faces of the cube is given by dou fx by dou y into dx dy into dz. So finally, we are going to arrive at an expression that is 3.41, which is considered as Gauss divergence theorem. Next, Stokes theorem, the fundamental theorem for curls, which goes by the special name of Stokes theorem. This theorem states that the line integral of a vector f around any closed curve C is equal to the surface integral of curl f taken over any surface S of which the curve C is boundary edges. That is, the surface integral S into del cross A into ds is equal to integration of A dot dl. Next, Biot-Savart's law. The magnetic field of a steady line current is given by the Biot-Savart's law, that is B is equal to mu naught by 4 pi into integration of I into dl into r by r cube. So here dl is an element of length along the wire and r is the vector from the source to the point P, that is as shown in the picture. Next, Faraday's laws of induction. In 1831, Michael Faraday discovered that current is induced in a conducting loop whenever a magnet is moved towards or away from the loop. The current is induced even when the magnet is held stationary and the loop is moving either towards or away from the magnet. However, When both the loop and the magnet are stationary, current is not induced in the loop. These observations imply that current is induced in the loop as long as relative motion occurs between the magnet and the loop. This phenomenon is known as electromagnetic induction. The current produced in the loop is called induced current and it is produced by an induced EMF. So Faraday summed up the above into two laws known as Faraday's laws of electromagnetic induction. The first law states whenever the magnetic flux linked with a circuit changes, an EMF is always induced in it. The second law states that the magnitude of the induced EMF is equal to the time rate of change of the flux linkage. Next, so here E is equal to minus d phi by dt, where phi is the magnetic flux through the surface bounded by the loop. If a coil consisting of n identical and concentric loops is used, and if the field lines pass through all loops, the induced EMF is given by E is equal to minus n into d phi by dt. Faraday's law states that an EMF is induced if the magnetic flux changes for any reason. It implies that an electric current is induced by a time-varying magnetic field. Next, here we come across Faraday's law in integral form. This is Faraday's law in integral form. We can convert it into differential form by applying Stokes theorem. That is del cross E is equal to minus dou B by dou T. Next, the equation of continuity. Electric charge can neither be created nor be destroyed. Therefore, the net charge in an isolated system remains constant. This is known as the principle of conservation of charge. This principle implies that the time rate of increase of charge within a closed volume equals to the net rate of flow of charge into the volume. This statement of conservation of charge is expressed by the equation of continuity, that is del dot j plus dou p dou rho by dou t is equal to 0, or del dot j is equal to minus of dou rho by dou t. So it expresses the principle of conservation of charge. Charge cannot flow away from a given volume without diminishing the amount of charge existing within the volume. Thank you.